Okay, so this is the final chapter, chapter 5, which is the data communication and computer network. So for chapter 5, if you look at your learn, there are 4 slides in total. So we have part 1, part 2, part 3, and also another slide, which I name it as extra notes. Okay, so basically chapter 5, majority of it are all theories. So for your final exam, usually the theoretical part comes, most of the theoretical parts come from chapter 1 and also chapter 5. Okay. Um, okay, so now let's continue with the chapter 5 part 1 here. So for chapter 5, we will cover on today, we will cover on the what is data communication, the definition of computer network, and also tasks in data communication. We will learn about the network components, the structure, types, topology model, network technology and applications. How can we calculate the network performance, transmission in data communication, and also how we can calculate the bandwidth utilization in data communication. Okay, so the first thing that you need to know is what is the definition of a computer network. Okay, so over here is stated that the computer network is an interconnected collection of devices, interconnected collection of devices or computers which are cooperative, autonomous, and mutually suspicious. Okay, so in Malay, basically is a rangkaian komunikasi. Okay, so we have several computers or several devices that is connected to one another. Okay, so this is what we call as the computer network. And this computer network is it is cooperative, meaning um all are working together, meaning all the computers here are working together. There is no master-slave relationship. Okay, and it is autonomous. Autonomous meaning that it owns freedom. Okay, freedom to act. Yeah. So these computers or these devices is capable of independent action and capable of refusing its own requests. Okay. And lastly, it is mutually suspicious, meaning that every component here can verify requests. Okay. So again, this cooperative meaning that all of these computers or devices it works together. Okay. So this is the meaning of computer network. So there are several tasks in data communication and computer network. Okay, so it is used as a transmission system utilization. It can be used for interfacing, signal generation, synchronization, exchange management, error detection, flow control, addressing, routing, recovery, message formatting, security, and lastly, network management. Okay, so the next one is let's look at the components in data communications. Okay, so if you look at this figure here, this figure is similar to the figure in chapter 1, the basic communication model. Okay, I hope that all of you still remember the basic communication model. So we have the sender, we have the receiver. Okay, in between here, we have the transmission channel. Okay, so this is the same thing. Okay, but for data communication, you look at here, the input here is in terms of protocol. Okay, and the receiver will receive the protocol. Okay, so the in between here, we have the same channel, the channel or the medium to send the message from the sender to the receiver. Okay, so what is protocol in data communication? So protocol is actually the set of rules that manage the data communications. Okay, a set of rules where we have the list of step 1, step 2, and step 3. So this is what we call as protocols, set of rules. So the agreement between the communicating devices, we need to have agreement in terms of the format of data, medium of transmission, and also the speed of transmission. Okay. So next is we go into networking, computer network. Okay, so there are types of connection. There are when the two or more devices are connected together through a links. Okay, so the link is a pathway that transfer data from one device to another. So the link here is actually the this channel or the medium. Okay, so there are two types of connection. The first one is the point-to-point connection. And the second one is the multi-point connection. So we need to know the important thing here, you need to know what is the difference between the point-to-point connection and the multi-point connection. Okay. So the first one, the point-to-point connection. Point-to-point connection is when you have one input and one output. Okay, so the first figure over here, you have one input, which is the mainframe. Okay, so this is the input, and you have the workstation. Okay, one input and one output, and you have a link or the channel in between here. So this is what we call as point-to-point connection. So one to one. Okay, same for this one. So we still have one input and one output. Okay, so now the input here is a workstation and another input is also a workstation, and we have a link in between. Okay, so this is point to point connection. Okay, remember one input, one output. For a multi-point connection, okay, for multi-point connection, look at here, we have one input, but several output. Okay, for over here, we have two outputs lah, and we have the link here to connect between the input and also the output. So this kind of connection we call as the multi-point connection or multi-drop connection. Okay, one input to more than one output. Okay, so for the point-to-point connection, okay, so this is the point-to-point connection where you have one input, one output. Okay, so this point-to-point connection is not practical. Okay, not practical, especially when these two devices are too far apart. Okay, and also it is not practical when you have large set of devices. Okay, so that's why usually we use the multi-point connection. Okay, so in order to overcome this point-to-point connection, we use the multi-point connection. Okay, so I'm sure that all of you already heard about the LAN, WAN, and also MAN. Okay, WAN and MAN maybe you haven't heard, but I'm sure that all of you have heard of LAN, local area network. So this local area network, wide area network, and also the metropolitan area network is falls under the multi-point connection. Okay, so next we will look into what is the local area network, what is wide area network, and what is metropolitan area network. Okay, so the categories of networks, the category of networks, you can determine based on the size, the ownership, the distance covered, and also the physical architecture. Okay, so you need to know this, okay, in order to determine which one is the best networks, type of networks to be used. Okay, so the type of networks we have three: the local area network, metropolitan area network, and also the wide area network. Okay, so first of all, let's look at the first one, which is the local area network and LAN. Okay, So for local area network, we have two types. We have single building. We have single building LAN and also multiple building LAN. Okay. So for single building LAN, the devices is limited in a single office, building or campus. Okay, so this is an example of a connection of a single building LAN. So you have several devices, okay, computers here, and connected to a link. Okay, but this connection is limited in a office, building or campus. Okay, so this is what we call as single building LAN. The second one is multiple building LAN. So based on the name itself, you can see that the multiple building LAN, it covers a wider network compared to the single building LAN. Okay, so this is an example of connection of a multiple building LAN. Okay, so the multi-building LAN is limited to a few kilometers. Okay, it is larger than the single building LAN, and it can consist of several topologies, which is the bus topologies, ring topologies, and star topologies. Okay, so what are the topologies? Later we will cover on these topologies. Topologies is basically the types of connection here. So if you look at, for example, this one, this is actually the ring topology. This is the ring topology. This is the star topology. Okay, and we also have the bus topology. So we have a different connection from multiple, more than one building here. Okay, connected to a single backbone. Okay, so this one is actually connected. Yeah. Okay. So all of these are connected to a single backbone. And for the multiple bidding LAN, the data rate is between 4 megabits per second to gigabits. Okay, so this is local area network LAN. Okay, the next one we have the metropolitan area network, which is the MAN. Okay, so we talk about metropolitan. Okay, you should expect that it will extend over entire city. So meaning that it covers a larger area compared to the local area network. Okay, and this metropolitan area network usually it is owned by private companies. Okay, so we have in the city we may have like the metropolitan area network to connect the city, different location. Okay. And the last one we have the wide area network. Wide area network is this is the widest one. Okay, so wide area network is used when you want to send information for long distance transmission over large geographical areas or continent. Okay, so for different countries, we can send the information through the wide area network one. Okay, so this one, it will utilize the public lease or even the private communication, okay, in combinations, meaning that it will combine not just the public, but you can also combine you use the public lease and also the private communication at once. Okay, so an enterprise network is the one owned by one company. Okay, so when you have the name enterprise here, so it's actually a wide area network that is owned by a company. Okay, so we have covered on the local area network, metropolitan area network, and also the wide area network. So the most important thing is that you should know the difference between these type of networks. So this table actually summarize the difference between the LAN, MAN, and also WAN. Okay, so this level is very important. Okay, so let's look at the first one in terms of the distance. So for the land, it has a very limited coverage. So it can only covers up to 2,500 meters only. Whereas for the metropolitan area network, it can cover the whole towns and cities for about 50 kilometers. And lastly, the wide area network is, of course, it can cover larger distances compared to the land and man. So wide area network, it can cover not just the state, but also continents. Okay. And the second one, let's look at in terms of the medium. So for the local area network, the medium that it uses is optical fibers, coaxial cable, twisted pair cables, and also wireless. For metropolitan area network, the medium it can only use optical fibers cables and normal cables. And for the wide area network, you can use the optical fibers, cables, and also wireless satellite. So the difference is for the wide area network, you have the satellite here. Okay, and for the local area network, you can the medium can be wireless, but the uh, metropolitan area network, there's no wireless medium here available. Okay, and the third one is in terms of the speed. Okay, if you compare in terms of the speed, the local area network has the highest speed. Okay, so the speed for the local area network is between 0.2 megabits per second to 1 gigabits per second. Okay, and it has a low latency. So what is latency? Latency actually meaning the delay. Okay, so it has low delay, less delay compared to the metropolitan area network and also the wide area network. So for the metropolitan area network, the speed is less than 100 megabits per second, and the typical latency is less than 1 millisecond. Okay, for the wide area network, the typical speed is between 20 to 2,000 kilobits per second only. And for the typical latency or the delay is between 100 millisecond and until 500 milliseconds. Okay, so over here what we can summarize is that if you want to cover a large area, then you can use the wide area network, but the drawbacks is the speed is less compared to the local area network. So the local area network, even though the coverage is limited, but the speed is have the highest speeds compared to the medium area network. Sorry, metropolitan area network and wide area network. Okay. So for chapter 5, part 1, so basically the important thing is that you should be able to uh, explain what is the point-to-point connection and also the multi-point connection, and also explain on the local area network, metropolitan area network, and lastly the wide area network, and able to differentiate in terms of the distance, medium, and also the speed. Okay, so this is for part 1. So basically today I would like to directly continue with part 2, chapter 5, part 2. Okay, so this we have finished for chapter 5, part 1. Okay, so for part 1 just now, in the slide, okay, so in this slide, I already stated that for the multiple building line over here, yeah, it can be you can connect different topologies. Okay, so topologies, we have several types of topologies. Example is bus topology, ring topology, and star topology. So for example, this one is the ring topology and this is the star topology. So basically this topology will be covered in chapter 5, part 2. Okay. Okay, so for chapter 5, part 2, we will cover on the network topology. So network topology is actually the study of the location, and we have two types of topology, which is the physical topology and logical topology. For physical topology, okay, physical, it will describe in terms of the wiring, the connection. Whereas for the logical topology, it will describe in terms of how the data flows within the network itself. Okay, so these are the types of topologies. We have the mesh topology, bus topology, ring topology, star topology, extended star topology, tree topology, irregular topology, cellular topology, and the last one is hybrid topology. Okay, and for this one, you should know the difference and also the connection. Okay, so the first type of topology is the mesh topology. Okay, so this is the example of the connection of the mesh topology. Okay, so the blue one here, the blue dot here, we call it as node. Okay, so over here we have 1, 2, 3, 4, 5, 6 nodes. Okay, so in mesh topology, every node is linked directly to every other node. Okay, meaning node 1 is connected to node 2, 3, 4, 5, 6. Okay, node 2 is connected to node 1, 6, node 1, 3, 4, 5, and 6. Okay, so every node is directly connected to one another. So that's why you have a connection that looks like this. It looks like a mesh. Okay, so however, this mesh topology, it is not practical. Okay, it is not practical, especially if the users are geographically distributed. Okay, why? Because if you look at here, we have a redundant connection. Okay, so the connection here is redundant. Okay, so it is not practical because the connection is redundant. So meaning you requires more many links. So this one I call it links. Okay, so since it's the redundant, so you requires more links compared to other topologies. Okay, so stated over here, the mesh topology is very costly. Okay, so the n number of users requires n times links. Okay, so n is a number of users lah. So if you have 6 users, then you requires n times n minus 1 links. Okay, even though it is costly, but still, due to the redundant connection, it still has its advantages. So this is the advantages. The advantage of mesh topology is that if any of the link fail to function, the information can still flow. Okay, so since the connection here is redundant, so even though one link is failed to function, the information can still flow through other links. Okay, so mesh topology is the simplest topology. It is simple and it is straightforward. Okay, so the next one, this is the bus topology. So bus topology, you will have a single cable that connects all computers or devices. Okay, so this is a single cable, single line here. So it connects all of the devices. Okay, so each of the devices has connected to shared single cable. Okay, so this is the single cable which we call as bus or backbone. Okay, so this single line here or cable we call it as bus. So that's why it is called bus topology. Okay, and look at here. Okay, so this single cable here at the end and also the start here we have the terminator. Okay, so the terminator is actually to signal that this is the end, okay, to signal that this is the physical end of the segment. Okay, so we have the terminator. So logically, for the bus topology, all devices can see all communications and each device is on the same wires. Okay, so same for this one, you have all of these devices are connected to a bus or backbone. Okay, so the next topology, before that, the advantages of bus topology is that it works well for small networks. Okay, and this bus topology, it is inexpensive and it is easy to add to it. Easy to add meaning, for example, if you want to add another workstation here, you can just simply add it. Okay, if you want to add another laptop, you can simply add it like this. Okay, but the disadvantages is that management costs can be high and it has a potential for congestion. Okay, because it is connected like this in series, and breakdown in the bus cable brings the entire network. So meaning if there's a breakdown in the bus cable, breakdown in the bus cable meaning this line over here, this is the bus. Okay, so if there's a breakdown and in the bus cable here, it will bring down all of these devices. It will bring down all the entire network. Okay, so the entire network will not be functioning if the bus is having a breakdown. Okay, so this is the disadvantage of the bus topology. Again, the next one is the ring topology. So ring topology, the connection looks like this. Okay, so the middle part here actually looks like a ring. So that's why we call it as the ring topology. So the computers is connected in cascade, okay, in order to make a closed loop ring. Okay, so it's connected in cascade to make a closed loop ring. Okay, so the source station transfers the information to the next station. Okay, so the source station, okay, the server, will transfer the information to the next station and so on. Okay, so there's a continuous path for data with no logical beginning or ending. Okay, so since it's a closed loop, so there's no beginning and there's no ending and there's no terminators. So it differs from the bus topology. So the bus topology, you have the beginning and also the end. For the ring, you don't have the beginning and the end. Okay, it is closed loop. Okay, so logically for the ring topology, each station passes data to the adjacent station. Each station will pass the data to the adjacent station, and the devices are wired in the daisy chain. Okay, so like this, daisy chain. So what is the advantages of ring topology? So it is easier to manage and easier to locate a defective node or cable problem. Okay, and for ring topology is very well suited for local area network, long distance on the local area network. It can handle high volume network and enables reliable communication. However, the disadvantages is that the ring topology, it is expensive. It requires more cable and network of equipment. So if a link or station breakdown, the entire network will also be disabled. Okay, so if you want to add a new client, it will disrupt the entire network. Okay, so actually for compared to this one, since this one you have a terminator, you can actually put the terminator somewhere in between here, and then you can add the new devices without interfering the network here. But for the ring, since you don't have the terminator, so that's why if you want to, if the entire network is disabled, the whole system will be break down. And also if you want to add a new client, Okay, if you want to add a new client, it will disrupt the entire network because you don't have the terminators here. Okay, so you need to you want to add a new system, a new client, then you need to stop this network first, then start it again. Okay, and then we have the star topology. For star topology, this is the connection. So we have a single hub at the center. Okay, and you have a connection like this. So the connection looks like a star. So the star topology is the oldest and the most common network. So for the star topology, this one, I'm sure that you have seen this before. Okay, so this is very common, meaning you have one single hub and this hub is connected to various devices. Okay. Okay, so usually the internet that we use at home, we have a single hub like this and connection like this. Okay, so this is what we call as the star topology. It is the oldest and the most common network design. So we have multiple nodes meaning this one, the workstation, the server, multiple nodes are attached to a central hub. Okay, so physically all nodes are connected to a center node. Okay, this is the center node and all data pass through the center. Okay, so if you want to send information, then all the data need to be passed through the center. Okay, so same for this one. This is also the star topology. So this is the hub. Okay, so everything is connected to the hub. So the advantage of the star topology, it is easy to design and install. Okay, and it has low startup cost and easy to manage and maintain. And the layout is easy to modify and troubleshoot. Okay, so this one is very easy if you want to add devices. So you just add it. Okay, so however, the disadvantages is that since all of these are connected to the hub here, so if the hub is having a failure, then all of this cannot be functioning at that time. Okay, and also the star topology, it requires more cabling compared to the bus topology. Okay, so the next one is extended star topologies or the E-star topology. So extended star topology is actually similar to the star topology, but you have the extended version. Okay, so over here is stated that extended star topology, it repeats the star topology. It repeats the star topology where each node that links to the center node is also the center of another star. So meaning for the star topology, you only have this part. Okay, so your center node is this one. This is for the original star topology. But for the extended star topology, you have another, for this one, this will become the center node for these nodes. Okay, and this will become the center node for these three nodes. This will become the center node for these nodes, and this will become the center nodes for these nodes. Okay, so this is the what we call as the extended star topology. Next, we have the tree topologies. Okay, so tree topologies, it is similar to extended star topology. Okay, similar to the previous one, extended star topology. However, the difference is that the it doesn't use one central node. Instead, it uses a trunk node. Okay, so for the extended star topology, we have the central node. So this is the central nodes for this. This is the central nodes for this node. Okay. But for the three topologies, we don't have the one central node, but we have a trunk node. Okay, so this is what we call as the trunk node. So example type of tree topologies is telephone networks. Okay, so telephone networks uses the tree topologies. And next we have the irregular topologies. Irregular topologies is when you don't have obvious patterns. Okay, so we cannot see any patterns like this one. Okay, so we call it as the irregular topologies. Okay, so the wiring is inconsistent. And the last one, okay, so this is the last one. We have the cellular topology. So cellular topologies, it looks like this. So cellular topology is different from the other topology. So it is used in wireless network. Okay? So that's why you can see the network topology looks like this because it is wireless. Okay, it consists of circular or hexagonal areas. And you have an individual nodes at the center. So if you combine several topologies together, we can call it as a hybrid topology. Okay, so for example, over here, this connection here, we have a one single hub connected to the bus topology, ring topology, and also the star topology. And this hub itself we call as the star topology. So the combination of these topologies we call as the hybrid topologies. Okay, so in order to determine which topology to be used, you need to consider all of this. Okay, the cost of installation and maintenance, the redundancy of the design. Okay, so remember if the link is, if you have a redundant link, the cost will be increased. However, the advantages is that if one point is broken, the information still can be transferred. Okay, and also in terms of reliability. So reliability meaning that there's no single point of failure. And then you need to consider in terms of expandability. Expandability meaning the capacity for you to extend the network or include a new devices into the network. And then the need for switching and the need for routing. Okay, so look at here. What is the difference between the switching and routing? So switching actually the process of directing traffic through network based on predefined route. Okay, so you direct the traffic through a predefined route. Okay, you already defined the route, but for routing, uh, the routing is actually the process of finding the best route. Okay, so it's different. And so for switching, you already have the predefined route. For routing, you will find the best route to be used. Okay, and also the last one you need to consider in terms of the delay. Then only you can decide which topology is the best to be used for your system network. Okay, so the next one is the network model. Okay, a network model is the functions and service provided by the network. Okay, so network model, we have peer-to-peer model and also the client server model. Okay, so what is peer-to-peer network? So peer-to-peer network, okay, there are no dedicated server. Okay, there are no hierarchy. There is no or meaning that over here you have the multiple device over here. The devices, all of these devices have the same function. Okay, all of the device is having the same function. Okay, so all of the computers are equal to one another. So this is what we call as the peer-to-peer network. So each devices, this device 1, 2, 3, 4, 5, and 6 will act both as the client and also a server. So for example, this one, it will act as a client and also the server. There is no one single server. Okay. Okay, there is no one single server or the administrator. All of your device actually act as the client and also the server. Okay, so for example, if device 6 can request something and the device 3 can respond. Okay, so all of these having the same function or equal function. All of these devices act as both clients and also the servers. So this is what we call as the peer-to-peer network. So different to the client-server network. So for client-server network, you have a centralized server. Okay. For the previous one, you don't have a server because all of these devices will act as the server. Okay. So for this one, for client server network, you have a single server. And then this server usually is a powerful computers, which requires a lot of memory and also storage space and fast network connection. Okay, so this server you must consist of large storage space and fast network connection. Okay, so please make sure that you able to differentiate between this client server network and also the peer-to-peer network. Okay, so in summary is that the client server network, you have one single server here. Okay, so and the other computers acts as the client. Okay, acts as the client. So if the for example client 2 requests, okay, so it requests to the server and the server will respond. Okay, all of it for the request, the client 1, 2, 3, 4, and 5, they can request everything to the server, and this server will respond to client 1, 2, 3, 4, and 5. For the peer-to-peer network, this device we don't call it as the client, okay, because for each devices, okay, it will act both as the client and also the server. So if you look at here, device 2, it can request and it can respond. Okay, all devices can request and respond because it acts as the client and server. This one only the client can only request and the server will respond. Okay, so this is just the examples of networking technologies that we already have. For this one, you can, if you want to know in details, you can just Google it up. Okay, so some of the network technologies is we have the internet, fast internet, okay, and okay, so the others you can just uh Google it up, and also the applications, okay, applications of the network technology. Okay, so this one, the HTTP, I'm sure all of you already seen this before, HTTP, but you didn't know what is the exact meaning of this HTTP or the www at the beginning of the when you want to like search something, right? The website, you have the www dot something. Okay, so we have the HTTP also at the front. So this HTTP is what we call as the hypertext transfer protocols. Okay, and we also have the e-learning. Okay, our e-learn is the e-learning. We also have the e-commerce, okay, internet banking and so on. Okay, so next let's look at in terms of the network performance. So this network, there are several terms that can be used to measure how good is the network. Okay, so the first one that we can refer is the bandwidth. Okay, So the bandwidth, you can get it in the unit hertz and also bits per second. So if your bandwidth is in the unit hertz, it's actually the range of frequencies contained in a signal. Okay, so it is the range of frequency because the unit is hertz. Okay. So for example, bandwidth of a subscriber telephone is 4 kilohertz. But if you have the bandwidth in bits per second, it actually means that the number of bits per second that a channel or a link or a network can transmit. Okay, but both of these are still the bandwidth, but the difference is in terms of the unit used. Okay, so if you have the bandwidth in hertz, so it's actually the range of frequencies. If your bandwidth is in bits per second, meaning is that it is the number of bits per second that a channel can transmit. Okay. So basically an increase in the bandwidth in hertz, it will result in an increase in the bandwidth in the bits per second. Okay, so it is directly related to one another. So the second term that we can measure is the throughput. Okay, so throughput is the measure of how fast we can actually send data. How fast we can actually send the data through a network. Okay, so over here it stated that T is the throughput and B is the bandwidth. T will always be less than the bandwidth. Okay, so example, if you have a network with a bandwidth of 10 megabits per second, can pass only an average of 12,000 frames per minute, with each frame carrying an average of 1,000 bits. So the question is, what is the throughput of this network? So basically, you should be able to expect that since your bandwidth is 10 megabits per second, then your throughput should be less than this. Okay, so your throughput, you should expect the throughput is less than the 10 megabits per second. And then we have the latency. Latency, before this, I already told you that is the delay. Okay, so delay is how long it takes for entire message to completely arrive at the destination. Okay, so there are 4 things that will affect the delay. The first one is propagation time. The second one is the transmission time. And the third one is the queuing time. And the fourth one is the processing delay. Okay, so the first one, the propagation time. Propagation time is the time required for a bit to travel from the source to the destination. Propagate, the time required for a bit to travel from the source to the distance. So you can calculate the propagation time by the distance, divide with the propagation speed. Okay, so for this example, what is the propagation time? If the distance between 2 points is 12,000 kilometer, assume the speed to be 2.4 10 to the power of 8 meter per second. Okay, so for this one, you can calculate the propagation time. Okay, this distance divide with the speed. So you will get the propagation time. Okay, so you can try this by yourself. Okay, you just divide this. So you should get the propagation time. Okay, so another one is the transmission time. So propagation time is the time required for a bit to travel from the source to destination. For transmission time is the time between the first bit leaving the sender and the last bit arriving at the receiver. For the transmission time, the formula is message size divided with the bandwidth. Okay, so if you look at this example, what are the propagation time and the transmission time for a 2.5 kilobyte per message? If the bandwidth of the network is 1 gigabits per second. Okay, so this one you just divide. This is the message size and this is the bandwidth. Same for this one. what are the propagation time and the transmission time for 5 megabyte message. So this is the message size, and the bandwidth is 1 megabits per second. Okay, so please try this 2 example to get the transmission time. And the last, okay, so the second last is the queuing time. So queuing time is the time needed for each intermediate or end device to hold the message before it can be processed. Okay, the time needed for each device and devices to hold the message before it can be processed. And the last one is the bandwidth delay product. Okay, so bandwidth delay product defines the number of bits that can fill the link. Okay, so let's look at the case 1 here. Assume we have a link with the bandwidth of 1 bits per second. Okay, so we have a link of 1 bits per second. Okay, sorry, this is the bandwidth. Bandwidth of 1 bits per second. And the delay of the link is 5 seconds. So you can actually calculate the bandwidth delay product. Okay. Okay, so you look at here, the bandwidth multiply with the delay product. You multiply the bandwidth with the delay product, you will get 5. Okay, so 1 multiply with 5, you will get 5. Okay, so meaning that 5 bits is the maximum number of bits that can fill the link at any time on the link. Okay, so can you understand this? So basically you have 1 bits per second with the delay 5 seconds. Okay, so you want to determine the maximum number of bits that can fill the link, okay, at any time. So you just need to multiply. Okay, to calculate the bandwidth delay product, you just need to multiply the bandwidth with the delay product. So basically, for 1 bits per second, 1 bits is 5 bits is the maximum number of bits. Okay, so you can send 1, 2, 3, 4, and 5 bits. Okay, at a time. This is the maximum. Okay, so 1 second you transfer 1 bit, 2 seconds you transfer another bit, 3 seconds, after 3 seconds you transfer another bit, after 4 seconds you transfer another bit, and 5 seconds you transfer another bit. So 1 bits per second you can transfer 5 bit maximum. Okay, so this is what it means by bandwidth delay product. Okay, so let's look at case 2. So for case 2, we have a link with bandwidth of 5 bits per second and the delay link is 5 seconds. Okay, so to calculate the bandwidth delay product, you just multiply the bandwidth with the delay. Okay, so 5 multiplied with 5, you will get 25. So basically 25 bits is the maximum number of bits that can fill the link at any time on the link. Okay, so for 5 bits per second, okay, with a delay of 5 seconds, so 1 second you can transfer the first 5 bits, 2 seconds you transfer another 5 bits, 3 seconds you transfer another 5 bits, 4 seconds you transfer another 5 bits, and 5 seconds you transfer another 5 bits. So in total, okay, 5 bits per second, you can transfer maximum of 25 bits. Okay, 5, 10, 15, 20, and 25 bits maximum. Okay, so the bandwidth delay product is important to determine the maximum number of bits per packet to be sent through the channel. And lastly, lastly is the jitter. Jitter is actually a problem if different packets of data encounter different delay and the application using the data at the receiver side is time sensitive. Okay, so if you look at this example over here, the delay is the same. Okay, the delay is fixed. 1 second every 1 second. Okay, But for jitter will happens if the delay is different. For example, for the first packet, the delay is 20 millisecond. Okay, this is what we call as the first packet. First packet, second packet, and then third packet, fourth packet, fifth packet. Okay, for this one, the delay is the same. 1 second, 1 second, 1 second, 1 second, and 1 second. But jitter happens if the delay of the first packet is different to one another. For example, the first packet, the delay is 20 millisecond. The second one is 45 millisecond. Another one is 40 millisecond. Okay. So if this happens, the delay is different, then the real-time applications that uses data will encounter the jitter. Okay, jitter. It is a problem of different packets of data encounter different delay. Okay, so that is basically chapter 5, part 1 and also part 2. So a lot of theory. Okay, so but okay, I just want to highlight that the important ones is that you should know this one, the connection for the types of networks, local area network, metropolitan area networks, and also the wide area network, and also the network topology. Okay, so all of this network topology, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. You should be able to explain and also to differentiate between this topology, and also you should be able, given a situation, you should be able to decide which topology is the best to be used, and explain why you said that the topology is the best. Okay, so any question for chapter 5? Chapter 5, part 1 and also part 2.
No, madam.
No dia banyak teori dekat sini.
Yeah.
Okay.
Doktor,
Okay. Ya.
nak tanya pasal topology issues tadi tu. Apa maksud dia pasal no single point failure?
No single point failure, meaning that yang ni mana?
Dekat selepas type of topology. Yang ni. Dekat reliability.
Reliability.
Itu.
Oh, ini.
Ah.
Okay, so near single point of failure ni maksudnya contoh ni lah. Saya bagi contoh yang star topology ni. Star topology ni dia, since the connection dia connect macam ni, so connect to a hub. So bila hub ni rosak, semua tak akan function lah. So this is what it means by single failure. Faham tak? Kalau mesh topology ni, okay, so kalau one nodes ni tak boleh function, okay, yang lain ni masih boleh function, boleh send information.
Okay, tu. Faham.
Okay, so basically dekat sini dia cakap topology design ni, so sorry saya cakap BM. Okay, so for this topology design, before you can decide which topology is the best to be used, you must consider this. Okay, the cost, the redundancy, the reliability. So reliability ni meaning there's no single point failure lah. You need to make into consideration this, for example, this one lah. Okay. If the hub is broken, if you don't want a single failure, okay, maybe you can consider the mesh topology. Okay, so it depends on your application. Okay, so even though yeah, if the application, for example, you want a very cheap network, okay, so you cannot use the mesh topology, okay, because the mesh topology is very costly, okay, but the good thing is that it has no single point failure lah. But if your application stated that you don't want a single point failure, you want a good reliability, but you don't care about the cost, whether the cost is high or not, you don't care about it, then you can use, for example, the mesh topology over here. Okay, so this is what it means by no single point, no single point failure for this one. Okay, so this is very important. So if you want to answer questions regarding to determine which topology, the best topology to be used, so you need to consider all of this and you need to able to explain. Okay, so any more questions? No, okay. So this one, this recording later I will upload in the YouTube. Okay, for your okay. Okay, nak kena stop. Okay, so I will upload in the YouTube for your reference later on to prepare for your final. Okay, so that's all for today. See you on on Monday. Monday is public holiday, right?
yes, madam.
Yeah.
Okay, so we will continue on
Wednesday.
Wednesday. And Wednesday we will have your feast too. Okay, so that's all. Thank you.
All right. Thank you, madam.
Thank you, madam.
Thank you, Dr.
Thank you.